Hello everyone, how are you? And this is our last video on basic math skills for science. Practice makes perfect, folks! So today we're going to talk about the relationship between maths and science, because maths is really the language of science, especially physics, and we use maths to show how the laws of the world work. And these are a couple of simple examples we will look at: Pythagoras' theorem and the circle equations. And we will look at these links between maths and the world. First, we have to look at right-angle triangles. So you may know these already. Of course, we know triangles. Triangles are shapes with three sides. But we're going to look at a certain kind of triangle, a right-angled triangle. Here is a right-angled triangle, and the right angle is marked with that brown box. It is a 90-degree angle, and it is called a right angle. And right-angled triangles are the easiest ones to work with, and the area of all right-angled triangles is a times b divided by 2, which we can see if we cut a rectangle in half. You will probably know that the area of a rectangle is just the length multiplied by the width, and there you have the area of that rectangle is a times b. But if we cut that rectangle in half along the diagonal, then we end up with a times b divided by 2, and that is the area of our right-angled triangle. So we need that when we go to look at Pythagoras' theorem. So, Pythagoras' theorem. Pythagoras was a Greek mathematician who showed the relationship between the sides of a right-angled triangle, and this was about 2,400 years ago, so one of the first great mathematicians. And the sides by the right angle are A and B, and the long side C is called the hypotenuse, and that is opposite the right angle. So the longest side of a right-angled triangle is opposite the right angle, and it is called the hypotenuse. Very funny sounding word. So Pythagoras' theorem says that for any right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So the square on the hypotenuse, that's c squared, is equal to the sum of the squares of the other two sides, a squared plus b squared. Okay, so let's look at proving Pythagoras' theorem, and this is not the proof that Pythagoras himself would have used, because he did not have algebra at that time. He did something different, but what we are going to do is construct a square made of 4 right-angled triangles like this. And we can see we have 4 green triangles and 1 purple square, and all together they make up one big square, and the area of that large square is going to be c squared. You can see the hypotenuse squared is c times c, and that's the area of the large square. Then we look at the area of each part, and we have 4 triangles, and each triangle has an area of a times b over 2, as we saw. With 4 of those means we end up with an area of 2ab. And that works because if we have 4 times AB over 2, which is the same as the area of the 4 triangles, then we can cancel the 2 and the 4, and that leaves us with 2AB. And then we have the area of the purple square, which is A minus B all squared. And we can see this because we have the base of the triangle, that's A, and we have the height of the triangle, that's b, and if we look at the diagram, we can see that the length of the side of the purple square is going to be a take away b, or a minus b, and then we square that. And what that gives us is that the area of the large square, c squared, is going to be equal to the area of everything else added up. So a minus b, all squared, plus 2ab equals c squared. So what we do next is we expand the brackets. We expand that a minus b squared. And how we do that is a little complicated. But what we end up with is a squared minus 2ab plus b squared plus 2ab equals c squared. And the way that you do that, I'm going to put that there. It's a 4-step process, which I will not go through in this video. But you can see that ends up with a minus b squared equals a squared minus 2ab plus b squared. But we can also see that we have minus 2ab and plus 2ab. Now, we do not need to know what a is, and we do not need to know what b is. We know that 2ab is going to be the same in the same triangle. So 2ab minus 2ab equals 0. We can cancel those, which leaves us with a squared plus b squared equals c squared. And that is the proof of Pythagoras' theorem. So if you're still not sure, and I did go through that very, very quickly, so just have a look at this. Here you have an animated diagram with a squared, b squared, and c squared on it. And I would just mention that a and b are backwards from the last slide. They are using the different a and different b for the short and the long sides. But you can see the black area does not change, but we just move the triangles, and then you can see that the black area c squared is equal to the black area a squared plus b squared. So that's Pythagoras' theorem in a visual form. So let's go from Pythagoras and triangles to the circle. So there's a nice circle that we have, but what do we call the distance around the outside of the circle? We call that the circumference of the circle. What about the distance across the middle of the circle, from one side to the other through the center? Well, that is called the diameter of the circle. And if we take just half of the diameter from the center to the edge of the circle, we call that the radius, which is half the diameter. The diameter divided by 2 equals the radius of a circle. So now let's look at the mathematical features of the circle. So if this circle has a circumference of 25.519 centimeters and the diameter is 8.123 centimeters, then what is the circumference divided by the diameter? What is that? Well, it's going to be 25.519 divided by 8.123, and that's going to equal 3.141. Now, that seems like a strange thing to do. Why would we want to divide those strange numbers by each other? And what is this 3.141? Well, I suggest you try this with some of your own circles. Go draw a circle and measure the circumference and then the diameter, and then see what the division is. Yes, amazing! If you've done that, you will find that the ratio of a circle's circumference to the diameter is always the same. If you take any circle at all and you divide the circumference by the diameter, you will always get the same number. And this number is a mathematical constant. So a mathematical constant is a special place where mathematics meets the real world, and they give us ways to link what we do on paper to what happens in the real world. And this mathematical constant is called pi. The ratio of a circle's circumference to the diameter is always the same, and we call that number pi. And pi is 3.141592653 ... Pi goes on forever. So that is the relationship between the circumference of a circle and the diameter of a circle. So we've showed that pi is equal to the circumference of a circle divided by the diameter, and pi is always the same. So no matter what circle you have, you can use pi, which means that if you want to work out the circumference of any circle, you just measure the diameter and multiply it by pi. So c equals pi times d. And if you want to use the radius, you can also use that. You can say c equals pi times r times 2, because the diameter is equal to 2 times the radius. That's often written as c equals 2 pi r. We can also use pi to find the area of a circle. Now, I'm not going to prove this, but the area of a circle is pi times r squared. So you take your radius of the circle, square it, and multiply it by pi, and you have the area of the circle. So those are the two basic circle equations which we use when working with our mathematical constant pi. So that has taken us to the end of our look at math skills. You may know these skills already. As I said, you will certainly study them again if you're going through a regular high school curriculum. But don't forget, practice makes perfect. The more you practice these math skills, the better you will get. And that is all for this set of videos. I hope you found them useful, and I will see you again in the next set of videos. Bye bye for now.